So we still are in the working with Kubernetes Objects section, and now we will see the Kubernetes Object Management. So let's go into it. Kubernetes Object Management. The kubectl command line tool supports several different ways to create and manage Kubernetes objects. This document provides an overview of the different approaches. Read the kubectl book for details of managing objects by kubectl. So, management techniques. Warning. A Kubernetes object should be managed using only one technique. Mixing and matching techniques for the same object results in an undefined behavior. So, we have the management technique imperative commands that operates on live objects, and it's recommended for development projects. It supports 1+ writers and has the lowest learning curve. After this, we have the imperative object configuration that operates in individual files. It's recommended for production projects and supports only one writer. It has a moderate learning curve. We also have the declarative object configuration that operates on directories of files, and it's recommended for production project. It supports 1+ writers, but it has the high. Now let's take a look in the imperative commands management technique. So when using imperative commands, a user operates directly on live objects in a cluster. The user provides operations to the kubectl command as arguments or flags. This is the recommended way to get started or to run an on-off task in the cluster. Because this technique operates directly on live objects, it provides no history of previous configurations. Examples: run an instance of nginx container by creating a deployment object. You will type kubectl create deployment and nginx --image nginx. The trade-offs of this technique. Advantages compared to object configuration are: commands are expressed as a single action word. Commands require only a single step to make changes to the cluster. The disadvantages compared to the object configuration are that commands do not integrate with change review processes. The commands do not provide an audit trail associated with changes. Commands do not provide a source of record except for what is live. Commands also do not provide a template for creating new objects. We also have the imperative object configuration technique, and in the imperative object configuration, the kubectl command specifies the operation that being create, replace, etc., and optional flags and at least one file name. The file specified must contain a full definition of the object in YAML or JSON format. So, see the API reference for more details on object definitions. Warning: the imperative replace command replaces the existing spec with the newly provided one, dropping all change to the object missing from the configuration file. This approach should not be used with resource types whose specs are updated independently of the configuration file. Services of type of load balancer, for example, have the external EPs field updated independently from the configuration by the cluster. Let's see some examples. Create the objects defined in a configuration file. kubectl create -f nginx.yaml. delete the objects defined in two configuration files, kubectl delete -f nginx .yaml -f redis.yaml. You update the objects defined in a configuration file by overwriting the live configuration. kubectl replace -f nginx.yaml. So let's see the trade-off of this technique. Advantages compared to the imperative commands are that object configuration can be stored in a source control system such as Git. Object configuration can integrate with processes such as reviewing change before push and audit trails. Object configuration provides a template for creating new objects. The disadvantages compared to imperative commands are that object configuration requires basic understanding of the object schema, and also object configuration requires the additional step of writing a YAML file. The advantage compared to declarative object configurations are that imperative object configuration behavior is simple and easier to understand, and as of Kubernetes version 1.5, imperative object configuration is much more mature. The disadvantages compared to declarative object configuration are that imperative object configuration work best on files, not directories. And also updates to live objects must be reflected in configuration file, or they will be lost during the next replacement. And the last technique, we have the declarative object configuration. So when a user is using declarative object configuration, a user operates on object configuration files stored locally. However, the user does not define the operations to be taken on the files. Create, update, and delete operations are automatically detected per object by the kubectl. This enables working on directories, where different operations might be needed for different objects. Note: declarative object configuration retains change made by other writers, even if the changes are not merged back to the object configuration file. This is possible by using the patch API operation to write only observed differences, instead of using the replace API operation to replace the entire object configuration. Examples: for processing all object configuration files in the configs directory and create or patch the live objects, you can first diff to see what changes are going to be made and then apply. So kubectl diff -f configs and then kubectl apply -f configs. So you can also do it recursively process, and then you can recursively process the directories. You can do this by using kubectl diff -r -f configs and then kubectl apply -r -f configs. So let's discuss the trade-offs of this technique, and the advantages compared to imperative object configuration are that changes made directly to live objects are retained even if they are not merged back in the configuration files. Also, declarative object configuration has better support for operating on directories and automatically detecting operation types such as create, patch, delete, and do this per object. The disadvantages compared to imperative object configuration are that declarative object configuration is harder to debug and understand results when they are unexpected. Partial updates using this create complex merge and patch operations. So that's it for today. Thank you.